For lesson 4, we'll be talking about determining the scale of a number line or an axis. So to start, let's look at what that actually means. So to determine the scale, you really just want to say, what is the number line counting by? Right? So here's two number lines to see how much of a difference changing the scale can actually make. So if I have this first number line that looks like it's counting by ones, it's going to be a little bit harder to plot some of these points because we don't have that many divisions here. So -1.5 I know goes right in the middle between -1 and -2. But then when I go to plot 3/4, now I have to kind of estimate more, right? So 3/4 is closer to 1 than it is to 0. So I can kind of estimate that it maybe is right here. So that's 3/4. 4/3, I know that that is the same as 1 1/3, which is a little bit more than 1, not quite 1.5. So if this is 1.5, maybe 4/3 is right here, just before it. And we're having to estimate quite a lot. -75 just a side note, 75 is the same as 3/4, but we also know that 75 is pretty close to -1. So I'm just going to go ahead and put it like right here. So a lot of estimating on this one. Now, if we go to use the more zoomed in number line, you'll notice that it's actually counting by not ones, but 1/2. So 0, 1/2, 1, 1.5, 2, 2.5. So this should be a little bit easier. So -1.5 is just this line here between the -1 and the -2. 3/4 we can actually estimate pretty clearly on this one. So if this is a half, then half of a half is a fourth. So we'd go 1/4, 2/4, 3/4, 4/4, which is 1 whole. So we can say that 3/4 is almost exactly right here. Okay, if we want to estimate 1 1/3, again, that was the 4/3. We're going to do, instead of this half line, we'll really have 2 lines in there to make the thirds. So it would maybe go somewhere like this. There's 4/3. Last one, -75, which again was -3/4. We can do the same thing we did for 3/4. 1/4, 2/4, 3/4, 4/4. So it's going to go right here. So you can definitely see the answer to this next part. The similarities and differences here. The second number line is just zoomed in. And the first one has a scale of ones, right? Well, we're going to count by ones. And the second one is going to count by halves. So the points are still in all the same places. They just look a little bit different because it's zoomed in the second one. Okay? So this is called scale. And we do this a lot with our axes because sometimes we have really big numbers and sometimes we have really small numbers. And when that happens, you need a scale that makes it so that everything fits and makes sense. If you have really tiny fractions, you don't want to count by hundreds because you wouldn't be able to see what was going on. All right? So taking a look at this graph in example 1, we actually look like we're counting by not ones, but 1/2. It's just not labeled on the halves. And what we want to do is determine the points and then do some reflections. So I already went through and did the coordinates. So here's how I got these answers. So point A is over 1, and then it's up 1 3/4. If this is 1, this is 1 1/4, 1 1/2, 1 3/4, 2. So that's how I determined that it was 3/4 and not a half or a whole. Same thing with B. It's not on the half line. It's not on the 1 line. So it means it's right in the middle, which is 3/4, or in this case, -3/4. Okay? And then it is on the half line for the Y value. C, we're going to go over 1 3/4 because we're not on the half anymore and we're not on the 2. So that's 1 3/4. And then it's right on the -1. D is easier. It's on both of the -2's. Now to do our reflections, what we need to do is remember our rule that we learned in the previous lesson. So if you reflect over the x, the y value changes to its opposite. Okay, so let's practice that. So remember, our points are x, y. So if the y value changes, that means the first number is x and it's going to stay the same. The second number is y and it's just going to flip to its opposite. First number stays the same. Second number becomes its opposite. First number stays the same. Y value becomes its opposite. First number stays the same. Y value its opposite. Okay? So now that's when you reflect over the x. When you reflect over the y, now you've got to change the x value. Okay? So reflect over the y. Go back to the original point. Now the x is going to be its opposite. The y is going to stay the same. Okay, so make negative 3/4 into 3/4 and then keep the 1/2. 1 3/4 becomes negative 1 3/4. Keep the negative 1. Negative 2 becomes 2. Keep the negative 2. Okay? So that's that. Now we want to look at these two questions below. Which points are in quadrant 1 or quadrant 3? You have to remember this rule with the C. So this is quadrant 1, this is 2, this is 3, this is 4. So when we go to do this, we just have to picture where they're going to go. So if A is reflected over the Y, it's going to end up in quadrant 2. If it's reflected over the X, it's going to end up in quadrant 4. Only point A is in quadrant 1. Okay? Now if we look at point B, it's in quadrant 2. If we reflect it over the Y, it goes into quadrant 1. So we'll put B prime, meaning we flipped it over. If we were to reflect it over the x-axis, it ends up in quadrant 3. So we can call that B double prime, meaning that we flipped it over. Okay, let's try point C. If we reflect C up over the x-axis, it goes into quadrant 1, so C prime. If we reflect it over the y-axis, it ends up in quadrant 3, so C double prime. Okay? And let's see, finally, point D. Point D is already in quadrant 3, so if we reflect it, it's going to go into 2, or it's going to go into 4, so that's it for point D. Okay, now the last question says, when you reflect over the x-axis, where do your quadrant 4 points end up? Well, so first of all, here's the x-axis. If we reflect over that and we're in quadrant 4, so down here, it's going to just go straight up into quadrant 1. Let's take a look at example 2. In example 2, we're trying to match the points to what's on the grid, okay? So I'm going to take a look at just the first one. Negative 2, negative 3.5. So remember, we go over to the negative 2 and then down to the negative 3.5. Negative 3.5 being between the negative 3 and the negative 4. So definitely this grid is counting by ones, and we're able to estimate further if we need to. Okay, so now we can do 3 over 2, which is just 1.5, and then 2 3/4. So we're going to go over to 1.5, so right between the 1 and the 2, and then up to 2 3/4. So just about to the 3. That's going to be point L. Negative 5/2 is actually just negative 2.5, and then 2. So we're going to go over to the negative 2, and then in between the negative 2 and the negative 3, and then we can go up to the 2. That's point K, and that leaves us with this last one, which must be point M. So we're going to go over 3, and then down, that's going to be negative 1.5 there, which is perfect. So that's point M.